Hello class. For this video, we are going to go through a review of chapter 3, and in particular, the topic of superposition. So let us consider a homogeneous linear differential equation. This one has order 2, but that isn't important for now. So let's remember what homogeneous means. Homogeneous means that every term in your differential equation has a factor of y, y prime, y double prime, or so on. So every term has a y in it. As you can see, this is true. Very often, you see homogeneous equations written so that everything else is on the left and you have a zero on the right-hand side. Linear just means that there is no multiples of y in any term. There's no y squared term, there's no y cubed term, there's no y prime squared term, there's no y double prime term, and so on. So every term has exactly one y in it. This is what it means to be a homogeneous linear differential equation. Now these homogeneous linear differential equations are important because the principle of superposition applies to them. This is what the principle of superposition says. If y1, y2 are two solutions to the linear homogeneous differential equation, let us discuss what it means to be a solution of a differential equation, just as a reminder. It means that if we replace y1 with y here, here, and here, taking the appropriate derivatives, then the equation equals 0. And the same thing as y2. So setting y equals y1 or y equals y2 gives you equality in the differential equation. So if we have these two solutions, y1 and y2, then the principle of superposition says that c1y1 plus c2y2 is also a solution for any constant c1 and c2. This means that 3y1 plus 7y2 is a solution. y1 minus 8y2 is a solution. 16.5 y1 plus 200y2 is a solution. So any two numbers you pick, you can stick it there with the c1 and c2, and you have a solution. And in fact, this covers negative numbers as well. So remember that you could have like minus y1, minus y2 also being a solution. The proof of this principle is pretty easy, actually. So these equations are 1 and 2. So we can multiply the first equation by c1. We multiply the second equation by c2, and we add them together. And what we end up with is that by distributing the derivatives, we get that c1y1 plus c2y2 double prime plus px c1y1 plus c2y2 prime plus qx c1y1 plus c2y2 on the left-hand side. On the right-hand side, c1 times 0 is 0, c2 times 0 is 0, so you just get 0. What this means, though, is that y equals c1y1 plus c2y2 is indeed a solution of your original linear homogeneous differential equation given here. And this is the principle of superposition, that if you have two solutions, you can just slap constants in front of each of them, add them together, and that will give you another solution for any constants c1 and c2.